Okay, you guys can start it.
All right. Hello, everybody. Today we're going to be reviewing some factoring quadratic expressions problems. So here are four problems. And I know that since we're doing like a pre-recording, you can't exactly ask, but we'll go over all the problems at the end. So I'll give you guys around 5 minutes to do these four problems, and then we'll see if you guys got it correct or not by the end. All right, so hopefully that was enough time for you guys to go through all of these problems. Now I'll just annotate on the slide and let's see the answers. All right, so for all of these problems, all four of these problems, we want to distribute the terms in the factored quadratic. So we want to get an expanded form. Now for the first one, if we recall correctly, the first thing that you should do is to multiply the two linear terms in each of the factored expressions. So it would be x squared, and then you would multiply this x into the constant in the other term, which gives us minus 8x. And then we would do the same thing, but with this term. So we would get plus 7x since we're multiplying the 7 to the x. And then we'd finally get minus 56. So combining like terms, we get x squared minus x minus 56 for the first problem. Now for the second problem, we repeat the same process. X squared, combining the two linear terms, combining the linear and the constant terms, we get plus 4x and minus 9x. And then multiplying the constant terms, we get minus 36, which gives us x squared minus 5x minus 36. Now for the third problem, same thing. Multiply the linear terms, multiply the constant and linear terms, and combine like terms. So it'd be x squared minus 4x minus 12. Same thing for the last problem. Combine like terms. Then you would get x squared plus 2x minus 15. I'll give you a second to go over that, and then I'll clear the board for the next slide. All right, hopefully you guys got all that. We're gonna move on to the next slide now.
All right, so those were the first 4 practice problems. Here's 6 more problems. I don't think we have to do all of these. Let's do number 1, 2, 3, and 5. Let's do 1, 2, 3, and 5. So skip 4 and 6. They're a bit redundant, I think. 1, 2, 3, and 5. So you're basically factoring each of these quadratics into the pairs that we saw in the first slide. I'll give you around 5 minutes, same as last time. All right, I think that should be enough time to finish these 4 problems. If it wasn't, you could always just pause the recording and finish them first. I'll go over the questions. I'll go over the answers now. For number 1, we are factoring x squared plus 11x plus 30. So when factoring, we first look at the coefficient of x squared. In all these 4 cases, we see this as 1, right? So it's just 1 times x squared. that means in the two factors we have, the first term will just be x. Now we look at the second coefficient right here, plus 11, and the third one right here, plus 30. So what we look for is two numbers. They don't have to be whole numbers. Two numbers that multiply out to get 30. So if we call these plus A plus B, A times B would be 30, and then they add together to get 11. So A plus B is 11. And doing a bit of guess and check would be the best way to do this for smaller numbers. And we see that A and B should be 5 and 6. So if I erase this, we see that the answer here would be positive 5 and positive 6, because 5 plus 6 is 11 and 5 times 6 is 30. So this would be x plus 5 and x plus 6. Number 2, it's basically the same thing. So we look for two numbers that multiply to get -4 and add together to get -3. As a general rule of thumb, if you see two negative signs, so the addition is a negative sign and the subtraction is a negative sign, then you should know that one of the numbers is positive and one of the numbers is negative. So for this one, we see that 1 times 4 is 4, and then 1 times -4 is -4, which would be correct because 1 plus -4 is the same as 1 minus 4, which is -3. So it'd be x plus 1 multiplied by x minus 4. And finally, let's look at the third problem, x squared minus 14x plus 49. Now, this is a special case. The solution is special. So we look for a number that multiplies to get 49 and adds together to get -14, which tells you that both of the numbers should be negative. Now we see that 49 is 7 squared, so 7 times 7. And -14 is the same as -7 times -7. So we know the answer is x minus 7 multiplied by x minus 7, which is just equal to x minus 7 squared. Oh, sorry, x minus 7 squared. And now we look at number 5. This one is interesting because you see the last number here isn't a whole number. We see that it's x squared plus 9x plus 81 over 4. So looking at this question, we see that the last number here is not a whole number. So we know that at least one of the numbers in the factors are not whole. And here we can see that 9 over 2, so the fraction 9 over 2 multiplied by itself gets you 81 over 4. Now, how did I see this? Because 81 is just 9 squared, and 4 is just 2 squared. So it makes sense that 9 over 2 times 9 over 2 would be 81 over 4. And we see that 9 over 2 is just half of 9. So 9 over 2 plus 9 over 2 gets you 9. So we know that both of the factors are just 9 over 2. Right here, which is also equal to x plus 9 over 2 squared. All right, I'll give a minute or so to copy down the answers. Hopefully all of you have copied down the answers. If you haven't, as always, you can just pause it, right? And we can move on to the next slide, I think.
All right, so now we move on to completing the square, which is another useful tool that we always would try to use when solving a quadratic. So here's a problem. Now the problem asks you to use completing the square to rewrite this into a quadratic in its vertex form. Now remember, a vertex form is when a quadratic has a vertex in its equation represented by the points h and k in the form of y equals 8 times x minus h squared plus k. Now take a moment and try to do this. Hint, you add a constant to the quadratic in order to make the completing the square possible. I'll give you 3 minutes for this problem since it might take up quite a bit. All right, so hopefully you were able to solve this problem within the time range. If you were, that's great. It means that you're really understanding the material that we're teaching. But in case you haven't, that's okay because this problem is very algebraically intensive since we have to deal with a bunch of variables and such. Okay, I'll go over it right now. Okay. So as you may recall, whenever we have a perfect square quadratic that's factored, we get x plus a times x plus a. And we notice that the constant term is always equal to a squared. And the linear term is always equal to 2a. Now we apply that here. When we try to complete the square, I wrote that. We set this equation to 0. We divide everything by the lead coefficient, which is a. So we get x squared plus b over a, x plus c over a equals 0. Now we move c over a over to get x squared plus b over a x plus equal to negative c over a. Now we just have to add to each side the square of 1/2 times the coefficient of the linear term. Here, I'll show you. We'll do the same step once again, x squared plus ba times x. Now we have to add the square of b over 2a. And we do that to this side as well. Now, if we expand this out and factor, we get x plus b over 2a squared plus c over a minus b squared over 2 4a squared. Now that was very algebraically intensive, so I'll give you a few moments to write that down. All right, I hope that you got that one down. If you haven't, you can always pause and go back to check. We'll be moving on to the next slide now.
All right, so these are more specific cases of the previously shown problem, where we see that each is a quadratic equation set equal to y, and you have to write each of these quadratic equations into its vertex form. So I think let's take 6 or 7 minutes to do this. This is harder than the previous problems. And then I'll go over the answers. All right, I think if you're not done yet, I don't think you would be done yet. If these four problems take some time, I would recommend you to pause the video, try to finish the problems on your own first, and then you can keep watching the recording because right now I'll go over the answers to these questions. So we see the answer to the first question, y equals to negative x squared minus 14x minus 59 is y equals to negative x plus 7 squared minus 10. So how did we get to this answer? I think I will annotate on the side over here. So over here we see y equals to negative x squared minus 14x minus 59. So this time, instead of setting this part equal to 0, it's already equal to y. So we just keep it like that. And the first thing we have to do, as always, is make this coefficient just positive 1. So right now it's negative 1. We write over here that we divide both sides by negative 1. So it would become x squared plus 14x, right? X squared plus 14x plus 59 is equal to negative y, because you're dividing both sides by negative 1. And now the second step is to move this constant over to the other side. So this would be x squared plus 14x is equal to negative y minus 59. And the third step is you take the 14 divided by 2, square it, and then add it to both sides. So in this case, 14 divided by 2 is just 7, and 7 squared is 49. So x squared plus 14x plus 49 on both sides. So this side would be negative y minus 10. Yeah. And this side is just a perfect square. And it would become x plus, again, just half of this, x plus 7 squared. And equals to negative y minus 10. Move the 10 to the other side. X plus 7 squared plus 10 equals to negative y, and you can multiply both sides by negative 1. So the answer becomes, I don't need to write it here, but the answer becomes y equals to negative x plus 7 squared minus 10. It is pretty much the same thing for number 2, so I don't think I will have to go over it. Just follow these same steps, but just with different numbers, is what number 2 is, and we'll show the answer. Let's see, how do I erase this? Okay, and the answer should be, for number 2, the answer should be y equals to x minus 1 squared minus 6 is what you should get after you factor it out. Again, it's just the same steps as the first one using different numbers. Now this one, the third one, is slightly different. You see that y is not by itself. So what we have to do is to isolate y, right? So we look over here, we can distribute this side first. The first step would be to write it out as half of y plus 4 divided by 2, which would just be 2, equals to, keep this in the parentheses. Because at the end, you want to have this type of term, and this is already in that form, so you just keep it there. You don't distribute it. And it's just basic algebra. Half y is equal to x minus 7 squared minus 2, and you multiply both sides by 2. So 2x minus 7 squared minus 4. And that should be the answer for this one. Yes, okay, good. And this final one is much simpler, to be honest. I think I can do this one as well. So this final one is much simpler. It should be just y equals to x plus 3 squared minus 6. You just move the 6 to the other side, and you're done. I think that should be it. Do we move on to the next slide?
I think we transition to the transformations unit now, because this
All
is
right.
the last quadratic exercise that we're doing. Yeah.
Okay, so let's do it like this. Actually, I'll just quickly move through the next few practice problem slides. If you want to, you can pause the video recording and do them by yourselves. We'll also show the answers for them. So this one is just graph y equals x squared minus 2x minus 3. And the vertex is 1, -4, the x-intercept, the y-intercept, and the graph. The next slide, graph y equals negative x squared minus 6x minus 10. And this would be the graph. And I think that's it. All right.
Cool. Okay. So I think, Liz, do you want to share screen or you want me to do?
Can you share screen? Yeah, I kind of messed up my sharing screen. Sorry.
No problem. Yeah. Okay, so since today is our review lesson, so we will moving on to the transformation thing that we learned before. Okay. So this is our practice problem, like word review problem. So let's like do a couple questions together and you can do it by yourself after. So for the first one, it says 5 units to the right. So you just move every point to 5 units to the right, which means you plus 5 to the x coordinates. So 1, 2, 3, 4, 5. Same thing as G and T. Make sure you like measure it, like here's 2 units like that. And
Wait, Tracy, you have to move it up 1 unit.
oh yeah, just like and then you from there move 1 unit up, which okay, never mind, is graph is mixed up. So and then where is it? 1, 2, 3. Okay, never mind. And then after you move 1 unit up, here's G. And since here is 4 units, so 1, 2, 3, 4. And then 2. And yeah. Okay. There you go. Okay. That will be the first one. Let's do one more together and you guys can do it by yourself. Liz, you wanna do?
Okay, so I'll go over the second one with you guys. So translation says 1 unit to the left and 2 units up. So 1 unit to the left means we will do x minus 2, sorry, x minus 1, and then y plus 2. So this is what you will do to your coordinates. So the way Tracy did it before is by counting. So I'll show you another way to do it. So here y, you can see it's at -3, 0. So to move it to the point, you can do -3 minus 1. And then 0 plus 2. So here you will get -4, 2. And that will be your new point, just right here. And then your next point will be, G. And then here you have 0, -2. So you will do 0 minus 1 and -2 plus 2. And then you will get -1, 0, just right here. Wait, no, that's not where it is. Just right here, G prime. And then for the last one, you have -3, 4. And you will be getting -3 minus 1 and then 4 plus 2. And also these here, like for y and g, I was doing incorrect notation, just so you know. It's like correct ways, like here for m. So you will get -4, 6. Oops, sorry, that's negative. So -2. So -4, -2 is right here, m prime, and then your triangle would be right here. Yeah. Okay. So here's two ways that you can do it. You can either do the counting or do it algebraically to show your work. So you guys can try the other two now. I'll give you guys about 3 minutes because these are pretty easy. All right, so that was about time. Ifan can go over number 3 with you guys.
Okay, so annotate. So for number 3, we just pick a point, for example, this Q, right? And it's 3 units down, so count down 3. 1, 2, 3, right here. And then you count down 3 too. Oh, and L E. And you just connect them. It's kind of bad, but it's fine. It's still a triangle. Okay, for number 4, so we still pick a point. Yeah, thank you. For number 4, we still pick a point, for example, the E, and then we have 5 units to the right and 2 units up. So 5, 2 up, right here is the X prime. And then, so since this one's 2 and that one is 1, so you just count down 2 and 1 and you connect them. Sorry. And then that's it. And you add the prime. Yes.
Yeah, cool. Let's moving on. Okay, never mind. Here's the clearest graph. Okay, so okay. So right now you're gonna describe just like the problem that right here. So describe like translation, for example. Okay, never mind. Let's do a example first together. Okay, so since the black one was the original one, so you just counted 1, 2, so no, 2 unit down. Okay, and let's count.
1 unit down.
Oh, never mind. Okay, yeah, thank you. Okay, I'm going crazy today. So 1 unit down, and then for okay, and then 1, 2, so 2 units right. Okay. Okay. And then that should be the answer. Okay. So Liz, do you wanna go over it one more? And then they can try.
Sure. So for number 8, you can see the black quadrilateral is the original one, and then the blue one is the translated version. So let's pick this point T right here, just right here, and then the coordinates right here is 3, comma, -1. And then for T prime over here, you see 2, comma, 0. So over here, you can see that the points got translated one less, which means to the left on X. So left 1 unit, and then up 1 unit. Yeah, and also you can count, up 1, left 1, and this is just the algebraic way to do it. So now you guys can try 9 and 10, and these are really easy, so maybe like 1 minute, and then Ifan can go over them with you guys.
Okay, I'll start it. So for number 9, we'll pick 1 point, for example, the U, and then we can see obviously it only move right to the 1. So right 1 unit. Yeah, that's it. And then for number 10, we pick 1 point, for example, the L, and then we can see that it goes down for 1, 2, 3, 3, and 3, and then to the right for 1. So it's down 3 and right 1. Yes, that's it.
Okay, so make sure you check your answers. Okay. Yeah, you can check it again. Okay. So here's the key concept reflection. Hope you guys already got done before. So let's get into our practice problem. Okay. So first one, reflection across the x-axis. So here is a x-axis, right? Wow. Never mind. You guys already know. So okay. And then since the formula is like negative, you change your x coordinate to negative. So wait, no, never mind. Oh, okay. You change your y-axis to negative. So A, and then let me like graph it first so you guys can see. 1, 2. So here is the A point. A prime. D is right here. D prime. And and okay. And then we can connect together. Okay. So that should be it. And next one will be reflection across y equal negative x. So let me see, is there other questions? Okay. Do you guys want to try it by themselves or we can go over it?
They can try them first.
Okay.
We can just shorten the time.
Mm-hmm.
Actually, guys, you can pause this video right now and do it and then come back, resume. So I'll go over it right now, but don't look at this after you've done it.
Yeah.
Okay. So reflection over y equals x. So I'll first write down the formula. So for y equals x, the coordinates xy changes to negative y comma negative x. So a way to do this is to again look at the coordinate points and then change them. So here we have S and the point is at 2 comma, wait, that's not 2, 4 comma 2, right? And then T here we have 5 comma negative 2, and then J we have 4 comma negative 3, and then for A we have 3 comma negative 1. So change the coordinates to negative y and negative x. For s prime, we will have -2, comma, -4. So we can graph that right here, -2 and -4. So that'll be our s prime. And then for t prime, we will get 2, comma, -5. So 2, -5 is right here, t prime. And then for j prime, we will get 3, comma, -4. So 3, -4, just right here. And then for a prime, we will get 1, comma, -3, which is 1, comma, -3 right here. And then to connect them, okay, that looks really bad. But the line y equals -x is right here. So you guys can kind of see it. Wait, did I graph something wrong? I don't think so, but that looks very wrong. Wait, hold on.
Well, it's just a line, I think, but you did it. I think it's right.
Okay. Yeah, so that's how you do it, I think, if I'm correct. Yeah, okay. So Yifan can go over the next one.
Okay, for number 6, let me annotate. So the formula is x, y to the wait, what was it? Yx. Okay, you see the formula right here, and then we can find, okay, so find some point. It's like, for example, h is -2, +3. Yeah, okay. And p is -3 and -2. And then we use the formula above to transform it. So -2, 3 will be 3, -2. And the -3, -2 will be -2, -3. Wait. Oh my God. Okay. Yeah. And then we'll just graph the point. That's h. Oh my God. H prime and p. Where's p? -2. Right here. And then since that, this is, okay, I have to do all of them. Since I run out of space, I'll just do it here. For point Q is, what was it? -2, 1. So it will be it will be 1, -2. For letter L, it's 0, 2, and it will be, oh my God, it will be 2, 0. And then we just graph the point 1, -2. What? 2, 0. Wait, why did this one look so weird? L prime. It should be here. Wait, I'm confused.
Let's check it together. So 1, 2. Here's -3 and -2, right?
Mm-hmm.
So your change will be 2, 3, which is right here. Is that right? 1, 2.
I don't think
Yeah.
you use the sign. Do you?
Okay. And then here is P prime, and then H.
Wait, no, it's not right. It's -2, -3.
Oh, yeah, that's right. Never mind.
Let's just like clear this page and then like redraw everything.
-3, -2, -2, 1, 2. Here is probably P prime, right? And then 2 here. Here is L prime. Here is H prime. And Q prime. So you were connected. I don't know, is it right? But let's try. So it should be, since here is y equal x.
I think it's something like that.
Yeah. Okay. Then that's probably it.
It's like this way. Like that.
Oh, yeah. Okay.
Yeah.
Here. Yes. Okay, let's see next one. Probably have. Okay, never mind. Okay, here's the graph. It's kind of messy, but you can probably see it. Let me redraw it. It's kind of weird. Okay. Yeah, it should be like that. Okay. Yeah. That's it, I think, for today. Yeah, I think that's it. So if you guys have like any question, just leave it for next class. And yeah, just make sure if you guys didn't send 于思老师's volunteer hour, just send it. Actually, did Liz and Ethan got
Idioms and some inspirational quotes. So the first one is a bad thing never dies. Uh, for example, this guy is so evil and vicious that people still remember his fearful figure. He's probably a typical symbol of a bad thing never dies. So seeing this idiom, a bad thing never dies, you may associate it with legend never dies, but this idiom means the opposite. So admittedly, they are pretty close. However, what left to the future generation isn't the legend of someone, but instead of the legend, it will be infamy, which simply means a bad reputation. So if you use this idiom, like if someone did committed a really bad crime, uh, you can say and then after a few decades or even a few centuries, the people still remember uh, this guy's bad behavior, like what he did in the past, uh, and they think that and they still think that that guy uh, is very bad because he did that. So that's called a bad thing never dies. Like it never dies in people's heart, even though the person who committed this crime has already died. So the next one is break a leg. It means to wish someone good luck. So if you are to tell the actor to break a leg, you're wishing them the opportunity to perform and get paid. That's kind of weird, but it is what it is. The sentiment remains the same today. The term means good luck, give a good performance. No matter which version you believe, well wishes. Always appreciate it. And then the idiom "a closed mouth catches no flies." It sounds weird, but so for example, if you control your appetite well, no disease will come to you. That's what it means. So maybe the idiom sounds like a real flies like this looks really ugly and like egregious, but actually it doesn't mean really catch a fly by your mouth. Rather, it means to eat the right food and avoid the diseases. So as we always say that like um like diseases always like most of them always enter your body through your mouth. Like when you if you eat something dirty like an expired maybe snack and like you'll probably get a stomachache after eating that expired food because it went bad the time you let it alone and so that's called that's called you catch a flies by your mouth. So a closed mouth catches no flies means that you simply don't eat bad thing, and then and thus you won't get infected by like something weird diseases. And the next one is adversity makes a man wise, not rich. It's similar to no pain, no gain. It means sufferings that can make a person strong and wise. So adversity means bad situation. This idiom can be interpreted in multiple aspects. It can mean suffering bad situation teaches a man to be strong and wise. Like it's similar to no pain no gain. Like only when you are only after you are trained, sort of trained by the by the situations that is not beneficial to you, or rather some situation that is blocking your steps. That always teaches you a lesson. Like for example, there was a time I was asked to climb a wall without anything other than my friends, and like there was a very tall wall, about 4 meters tall. But from that event, like we learned, the teamwork can make us do anything. And at the end, like this suffering teaches us this lesson. However, it doesn't mean that you can however, if you interpret it in another aspect, it doesn't mean that you can torture yourself deliberately just to get rich, because adversity only makes you wise. But most adversity won't, they probably won't give you money or cashes directly. And this wealth should only be earned by our own, like by our own wisdom and strength, not made by bad situations. And no bad situations will give you actually make you wealthy, because there won't be, if that's the it's it's probably not a bad situation anymore. So the next one is a fox may grow gray but never good. It simply means villains are always villains. So when you first hear about this idiom, you may think about this fox. Like a fox, it's always orange or like sort of red or brown, but it can grow gray, like in some species of fox. But this idiom doesn't necessarily mean a fox. So in English or in common tales in different cultures, animals like fox or wolf, they typically symbolize deceitful characters, which means like they always trick people, or like they lie to people, or they're bad. They're simply bad guys. Oh, I forgot to explain villains. So villains are opposite to heroes. It means it it typically means that like villains are bad guys. And the fox may grow gray but never good, uses a metaphor to describe that a bad guy may change his everything, like appearance, or like his attitude appear in front of you, but his evil nature won't be changed. Like he always has a bad, maybe personality, like but that's not that's not kind of that's not a definite like that's not to say every bad guy will act like this. It's just uh, a term that describes Like when you meet some bad guys like that, you use this term to describe them. And the next idiom is a good conscience is a soft pillow, which means doing good things make a night of good sleep. So conscience means warm heart, like it means the thoughts of like we have the thoughts or we have the intention uh, to do good things like helping others. Uh, like we usually use a soft pillow to sleep well, but like in this idiom, a soft pillow doesn't necessarily mean a soft pillow. Rather, like sleep well here means that you can relieve, which means like relief is to like to relax yourself from being annoyed by like just how to say maybe sort of like you're afraid of karma. And combining together this idiom means that if you know that you have a warm heart and thus you know you didn't do anything bad, so that you can relieve without panicking about the penalty after doing evil. Like in other words, you don't worry. You don't worry like someone will come and catch you and like send you in the prison after you do something. And whose slide is this? Can someone continue?
Can Ellen or Zoe continue?
Yeah. So beating around the bush is a way of like avoiding saying what you actually mean, and it's an idiom that can be used as part of a sentence, and it usually describes someone who avoids saying what they truly mean because they're either uncomfortable or nervous. And then to cut somebody's some slack means to not be so critical or like to be less harsh. And it's usually used when someone of higher power is being too harsh or like a bit mean to about someone else's work. And it's usually used when other people suggest them to not judge someone as harshly or severely. And then an example would be, I wish my boss would cut me some slack. He's always telling me what to do. And basically, this means I wish he would be less harsh on me, a little bit more easygoing, you know? And yeah. And then this one's much easier to understand because caught between a rock and a hard place basically means just to be caught between two difficult choices. And it's usually used when somebody is in a difficult situation where they have to choose between two equally unpleasant courses of action.
I don't see a share screen.
Okay, and here are other famous quotes of in English. So, for example, the famous writer William Shakespeare, which is from the UK. First sentence is a rose by any other name will smile as sweet, which means that not only a rose will smell sweet, like it may not appear in the form of a rose. So like some good thing may not like they may not come in a like a fixed form. It may come in different forms, but they will also like they all of them will like be good or something. And the next sentence also from William Shakespeare is that all that glitters is not gold, which means that like for example, there are something called um there's something called a fool's gold, which means kind of an alloy of iron, which looks very similar to the real gold, but like people will always misunderstand it. Like they will always misunderstand it as the real gold, and they dig it and like take them back to their home and find that they are not the real gold. So this is a good example of all that glitters is not gold. It means that something that may appears very shiny, but actually like they can be fake. And can any tutors continue?
Yeah, the next one is all the world's a stage and all the men and women are merely players. It's by William Shakespeare again. And I think that means like um like I'm actually not really sure what that means. Hold on, give me a sec. It's like people aren't like, my interpretation is like people aren't like uh like the world is a stage basically means like it's a show basically, and the people inside the show are just actors. I'm not really sure what it means. Can someone else help me out? Okay, if not, we can just go on to the next one. Ask not what your country can do for you, ask what you can do for your country. That's by John Kennedy. That basically just means be like nationalistic, I guess. Like do anything for your country. Don't expect just be like a patriot, basically. Next one is ask and it shall be given to you, seek and you shall find. That's from the Bible. I think that's referring to like God, I think. Like if you ask him for something, he'll give it to you. I think this means like if you try in something, you'll eventually succeed in it. Next one is 80% of success is showing up. This basically means like don't give up on things. Like even if you don't think you're gonna do well, like a lot of your success is just determined about showing up. Because if you don't show up, you won't succeed at all. I don't know about this next one. For those to whom much is given, much is required. So that's basically like give to others, like do unto others what you want others to do to you. Basically just saying like if others treat you well, you have to treat them well back. So the next one is we can skip that one. I don't know what that one is. Genius is 1% inspiration and 99% perspiration. That's like saying 99% of like most of like something that you accomplish is actually working. Perspiration means like sweating, right? And so like actually doing the work instead of just thinking, I guess. And then he travels the fastest who travels alone. That's kind of like being like independent, because like other people slow you down is basically what it means. These, I mean, how about like I have a dream that my 4 little children will one day live in a nation where they're by the color of their skin, but by the content there is, by Martin Luther King. He was like a blacks' rights activist. He held like many strikes, peaceful strikes, and yeah, and he gave this speech where he says like in his dreams that like in the future that his children won't be judged by the color of their skin. It's a very famous speech. I've always depended on the kindness of strangers. He's talking about society, how there's people are nice to them, I guess. I love the smell of napalm in the morning. I think that alludes to the Vietnam War, where they use napalm on like in the trees, like as a war tactic. It was actually a really devastating thing, and there was a lot of like moral consequences and arguments that arose from that. I think therefore I am. I think that's like a self-realization, something like that. Like if you're able to think, like you exist, basically. Just like knowing who you are. If at first you don't succeed, try again. That's another thing about perseverance. Just keep trying, don't give up. If you're going through hell, keep going. Another one, just persevere. If you want something done right, do it yourself. This is another like in the thing about like self-sustainment or independence or transcendentalism. If you want something said, ask a man. If you want something done, ask a woman. That's that's by Margaret Thatcher, a women's rights activist, I think. And I think she was around the time for like women's rights, like voting and suffrage for women, stuff like that. I'll be back. I mean, I've got a feeling we're not in Kansas anymore. That's from Dorothy. It's from I forgot what the movie is called. It's like something with the yellow brick road. It's a very famous movie, but I forgot the name. Yeah, sorry, the Wizard. Yeah, the Wizard of Oz. It's from the Wizard of Oz. It's pretty like I guess iconic movie. I've seen it like on one side. I forgot the name. Keep your friends close, but your enemies closer. That's like a pretty common phrase, I guess. Like keep your friends close, but like the people who you don't trust, you have to keep them closer so you can keep an eye on them, I guess. Knowledge is power. I think that's like an enlightenment kind of ideal. Basically, like knowledge is key. Life is like a box of chocolates. You never know what you're gonna get. So that's from Forrest Gump, a really famous character in a movie. It's like you don't know, like if someone gives you a present, like a box of chocolates, you don't know what they got you, like what kind of chocolates. So you have to like expect the unexpected, I guess. Like expect anything. Life is like riding a bicycle. To keep your balance, you must keep moving. That's another one of perseverance. You got to just keep going. May the force be with you. That's a Star Wars reference. I don't really know how to explain that one. No one can make you feel inferior without your consent. I think that's like, don't listen to what others say about you. Like as long as you know that you're like special, or like as long as you know that you're worth something, then what others say doesn't matter. Not all those who wander are lost. That's by J.R. Tolkien. He's a pretty famous author. He wrote like The Hobbit and stuff like that. Think that basically means like some people just like wandering. I'm not sure. Nothing is certain except for deaths and taxes. So that's from Benjamin Franklin. He's another like historical American figure. He was like considered one of the founding fathers. And he's known for his like brilliant inventions of the time. And like right here, this is like during like America's revolution against Britain, and he's just saying nothing is certain except for death and taxes. And taxes were like a main cause of concern during the Revolutionary War, and that's basically why it happened. And so that's why he says death and taxes. Parting is such sweet sorrow. William Shakespeare again, the poet, author, and he's just saying like, breaking up or leaving your family is pretty hard. Power corrupts. Absolute power corrupts. Absolutely. Just saying that the more power you get, the more corrupt you'll be. And if you have total control, you'll be completely corrupt. And I'm not sure what that means. One small step for man, one giant leap for mankind by Neil Armstrong. He's like the first astronaut to touch the moon. That's like what he said when he was on the moon. Basically means like, although he only took one small step, it's a giant leap for like science and space and technology. The love of money is the root of all evil, from the Bible. It's basically saying money corrupts, and yeah, the more money you want, like if you love money so much, you're gonna get corrupted by it. You're gonna toss away all like morals, all relationships, stuff like that. I don't know. The only thing we have to fear is fear itself. So that's basically saying fear is just a mental thing, and if you like get past this mental barrier of fearing something, you're not going to be scared of it. So what we fear is just the concept of fear, I guess. Well, yeah, and then the truth will set you free. It's just saying the truth, set you free from ignorance, I guess. There's no place like home, another Wizard of Oz reference. Just saying, where you at, it's like pretty good. I guess like appreciate where you are, like where you're from, like your home. 3 can keep a secret if 2 of them are dead. That's from Benjamin Franklin. I think that basically means like the only person you can trust is yourself. Yeah, it's better to have loved and lost than never to have loved at all. So this means like it's better to have like gone through like relationships and like loving people, even if you break up with them or like you lose them. It's better to have gone through that than to never have loved at all, right? To be or not to be, that is the question. It's by Shakespeare again. Not really sure what that means. To err is human, to forgive divine. So this is by Alexander Pope. Basically saying humans make mistakes all the time, but forgiving someone is like pretty hard, I guess. especially if like what they did is bad. Uh, United we stand, divided we fall. Aesop, I think that's like an Aesop fable. I'm not sure if that's correct. Those are like kind of like little like riddles for kids that like talk about morality and like morals, like the moral of the story. United we stand, divided we fall. It's kind of like if we're together, you know, we can do anything basically. And but if we don't agree, then we're gonna fall. That usually talks about like, you know, working together. What doesn't kill us make us stronger. So, you know, like experiences, like if you didn't die there, I mean, it makes you stronger if you've learned something from it, something like that, right? Whatever you are, be a good one. Just whatever you do in life, be good at it. I guess from Abraham Lincoln. You can fool all of the people some of the time and some of the people all of the time, but you can't fool all of the people all of the time. So just saying don't lie, like be truthful, because you can't fool everyone all the time. You must be the change you wish to see in the world. So if you want to see change, you got to do it yourself. Like stuff with like pollution, I guess. Like you can't just say, oh, someone else will, you know, clean the beaches. You just got to do it yourself because if everyone has that same mindset, nothing's gonna get done. Yeah, I mean those are the main ones.
So I'll complete something that like some of them that Alan didn't go through. So so the sentence elementary, my dear Watson, is from Holmes, which is the most famous detective, like fictional detective in the world, probably in the world, like Holmes. And Watson is kind of, it's like he's like Holmes' assistant. Uh, like it's kind of a sentence that Holmes always says when he like when he pointed out a truth and then Watson kind of appreciate him and Holmes kind of say this. I think that's kind of bragging himself. Uh, and then the sentence "hell is other people," which means it's telling you not to care about like others others like how others consider you. Like if you consider others' opinions, like others may think bad of you. Like you really feel like you're in hell. And I love the smell of the palm in the morning, which is it sounds simple, but it's kind of maybe it's kind of sad because like the place like the place during the war uh like they were bombarded by the by the armies from both sides and like it's expressing the how how bad a war is like to tell us to like to cherish the peace. And then the sentence, nothing is certain except for death and taxes. It probably means that it's expressing that like everything in the world is in a state of uncertain. Like you cannot, like although he's talking about deaths and taxes, here like it's actually the thing he actually wants to express is that like nothing nothing in the world is certain. We cannot easily predict anything. And the sentence from Theodore Roosevelt, "Speak softly and carry a big stick." It's associated with his big stick policy, which means kind of a solution in maybe in politics, like when you are being a representative of your country or some from your faction, um, like a very you don't speak like a very like childish man who like always be be uh straight about the always be straight like Trump like he always be straight, but like Roosevelt here he wants to express that you need to learn some some techniques in communication that you from you like a wise man always it's pretty close to the sentence before there which says like if you like it's similar to like men always speak and women always do, but like you know that's kind of a little discrimination, but here Roosevelt wants to express that like a wise man always they always do but not speak. Like you don't speak much, but you have a big power. You have a great power. That like if someone like spam you, you can just use your power, like show your power to make them like subject to you or something, but don't speak some useless sentences. And the sentence from William Shakespeare, to be or not to be, that is a question. I think to be here is probably one interpretation from this is like to live or to die. That's a question. But it can be interpreted in different ways. And that's why it's very famous in the world. And the sentence, two roads diverge in the wood, and I took the one less traveled by, and that has made all the difference. So that is a metaphor here, which is to say that, um, like for example, you have two choices on your life here. Like the first one is a choice that most people will choose, and the other one is a choice that a relative less amount of people will choose. And this is simply to tell you that you should choose the choice that less people has chosen and because that's sort of in some situation that's like you do something like that and that makes you different uh, from the mainstream, I guess. But this is not to say that like in all situations you choose the like minority because nothing is absolute. Okay. Finally, can someone go through this article? Like, can someone first read this article of one? Oh, wait a minute. Can someone read this article? Zoe?
Do you want me to read it?
Yeah.
Okay. All right. A Brief History of Time from the Big Bang to Black Holes is one of Stephen Hawking's bestsellers. It is a popular science book on cosmology. Hawking first published the book in 1988 with the intention to explain difficult theoretical concepts to laymen. Because Hawking wrote A Brief History of Time for non-specialist readers with no prior knowledge of scientific theories, he used non-technical terms about the structure, origin, development, and eventual fate of the universe, which is the object of study of astronomy and modern physics. Throughout the chapters of the book, Hawking explains basic concepts like space and time, basic building blocks that make up the universe, such as quarks, and the fundamental forces that govern it, such as gravity. He also writes about cosmological phenomena such as the Big Bang and black holes. Professor Hawking also discusses two major theories that modern scientists use to describe the universe, namely general relativity and quantum mechanics. Finally, the book also discusses the search for a unifying theory that describes everything in the universe in a coherent manner. Recent advances in science has confirmed many of Professor Hawking's theoretical predictions in the first edition of the book. The book became a bestseller and sold more than 10 million copies in 20 years. It was also on the London Sunday Times bestseller list for more than 5 years and was translated into 35 languages by 2001. Okay. Want to go over the questions or?
Yeah, that would be great.
Okay. So the first question, a brief history of time is about the study of the universe. So I'll give you, you can pause this video and see. Okay, yeah, and I believe the answer is true.
Could you explain like where are the like evidence?
Yeah, sorry, can you go back to the question really quick? Okay, it's about the study of the universe. Okay, so where does it say it's about the study of the universe? Okay, so in the third paragraph, I think, says Hawking explains basic concepts like space and time, basic building blocks that make up the universe, which is a key word right there, and fundamental forces. Yeah, it's if you look across the paragraph, you can see like the universe is kind of the main point. So I believe the answer is true. Hawking wrote the book for experts in the field. So you can, here, can you scroll? Yeah, okay. So you can pause the video and look for answers. Okay, and I think I think the answer is also, it's false, because in the second paragraph it says, he wrote it for non-specialist readers with no prior knowledge of scientific theories and non-technical terms about the structure, origin, blah, blah, blah. So this is basically just saying this is for normal people who don't know like these special words for these scientific terms. It's pretty simplified, so then anyone can understand it. Okay. Okay, Hawking's scientific ideas in the book are outdated. So I'll give you, you can pause the video and look again. And so I think that, okay, so if you see on the last paragraph, or sorry, on the third paragraph, the last sentence, it says recent advances in science have confirmed many of Professor Hawking's theoretical predictions in the first edition of the book. So that's basically just saying, recently, a lot of studies show that Stephen Hawking was right. And so that means it's not outdated. So the answer would be false for number 3. And if we want to check our answers. Yeah, okay, they're all correct. All right.
Yeah, so a brief who's Stephen Hawking? So Stephen Hawking is probably one of the greatest like scientists like in the world but like he got sick like since a really young age and now I think he has already died for about 3 or 4 years. But he got sick in a very young age, and as you can see, his like his facial expression is kind of really numb because his muscles on his face becomes like it's like it that this the illness frees his muscles on his face and including like the muscles around like all around his body and that doesn't block him from being really famous like scientist and like he really contributes to the most of the like prevailing theories of uh in the field of physics and especially quantum physics. Things about quarks and little particles in nanoscales. And um and, and I think it's and I think time is up. So other tutors, do you have other things to say? Oh, I forgot one thing. Like, I should explain some words in this article. Like, the intention, which means like you want to do something, and cosmology means the cosmos. Cosmos is probably it's similar to the word universe. So it's about the universe. And then the best sellers means like something that sold very well. Like most people will buy it. And no specialist means like if you say specialist, which that means that uh, someone is someone is good at something. But for non-specialists, which means it's also acceptable if you are not good at this thing. And astronomy means you do researches on the stars, planets, like the celestial objects in the universe. And the word phenomena, it means like something that you see and something that you see and you can discover something. Like this is simply means like like something you can see. Uh, for example, like for example, I use fire to burn some specific metals. Like I use fire to burn coopers. It will give me it will give me green fires, not blue or orange fires. That is called a phenomenon. And coherent means like you put different things together. That's called coheres something. And so in a coherent manner means it talks about like different topics in a general way. And I think that is pretty much it. So this is today's lesson. Thank you for coming.
Okay, thank you guys.
Thank you.